In this video, we'll use shader graph to create a cool looking force field. At the end, you should have something that looks like this. I'm sure Winston would be proud. Notice how the effect takes advantage of a new node called scene depth to show where it intersects with other objects. This same effect can easily be applied to create other cool effects like foam in water or a sci-fi scanner. But before we get started, this video is sponsored by Skillshare. Skillshare is an online learning community with more than 27,000 quality classes on game development, tech, and more. If, for example, you don't have any prior experience in Unity but really want to make your game idea come to life, this course teaches you the basics of Unity without having to write any code. At the end of the course, you will even have created 2 gaming classics, Breakout and Doodle Jump. Skillshare is the perfect platform to keep learning and thriving, and a Skillshare membership gives you unlimited access to all classes for less than $10 a month. Join more than 7 million creators by simply clicking the link in the description, and the first 500 people will receive their first 2 months for free. Also, special thanks to Infinity PBR for his support on Patreon, and with that, let's get shading. So first of all, you want to make sure that you're using Unity 2019.1 or later. And Shader Graph now works with both the lightweight and the HD render pipeline, but no matter which one you're using, you should go to Window, select the Package Manager, select the render pipeline you're using. In this case, I'm using lightweight, and make sure it's completely up to date. If you don't know how to set up your project for lightweight, I'll make sure to have a link on how you can do that in the description. Now, in order to create this force field effect, we of course need to create an object that will have our material. So let's go to the hierarchy, right click, go 3D object, and let's select a sphere. Let's also scale this up, and I'm just going to put it next to the wall here. Something like that. Notice how I'm making sure that this object is intersecting with other objects so that we can see this part of the shader working as well. And now we're ready to create our shader. So let's go to the project, hit create. Let's go to shader. And here we want to select PBR graph. Let's call it force field. And we now want to create a material from this shader. So we can just right click on it, go create, and then material. And it's then going to automatically create a material with this shader selected. I'm just going to call this material force field as well. Let's then take this material, drag it in, and apply it to our sphere. And now it's almost time to jump into Shader Graph, but first we need to go and find our lightweight render pipeline object. So in my case, I'm using the high quality one right here, which is what it's using by default when you set up a new lightweight template project. And we want to make sure that under general, we have depth texture set to true. That's because we're going to be using the scene depth node to create this effect, and that requires a depth texture. Otherwise, that node is just going to give us a gray output. And now we're ready to jump into Shader Graph. So let's double click on our force field shader, and it's going to open up in a separate window. I'm just going to full screen this. And at this point, it's shader time. Now I would say this effect can be split up into 3 main parts. The first one is the intersection. So we want to create kind of a glowing effect wherever this object touches other objects. The second one is just a general glowing outline for the parts that aren't touching anything. And the third one is a scrolling pattern that we can kind of overlay. So let's start with the hardest part of this shader, which is the intersection. So the first thing that we're going to need is to access our scene depth. So to do this, we're going to go and create a scene depth node. And this is going to get the camera's depth buffer, and we can choose how it's going to sample it. We are going to choose I, which means that it's going to be converted to I space units. Why this is important is a bit difficult to explain. For now, just go with me. We are also going to access the screen position. So let's go ahead and create a screen position node. And here we're going to set the mode to raw. And basically what screen position does is it accesses the mesh vertex screen position. And why is this useful? Well, it's useful because we can know how far away a vertex is and then compare that to our scene depth buffer. And in fact, if we subtract this vertex distance from our scene depth, we're going to get a cool intersection effect. So to actually do this in practice, we want to split up our screen position. So we'll input it into a split node, and we only want to use the very last component here, so the alpha value. And we're going to simply take that and subtract it from a scene depth. So let's go from scene depth into a subtract node. And let's go from our alpha of a split into that subtract node. And that should in fact already be working in theory. So what we can do now is take this entire thing and let's plug it into the emission of our PBR master node. This is just temporary, but it should allow us to see kind of what's going on. I'm also going to go to our PBR master node and change the surface type to transparent, because we're going to be working with transparency. And now if we save this asset and go into Unity, voila, we can see kind of what's going on here. We have this fading gradient wherever this object intersects with the wall. Now it looks a bit weird from the other side here currently, but we can see kind of the same thing happening. And the main reason why this is currently looking weird is because our sphere is also casting shadows. And we really don't want that for this effect. So let's select our sphere. Let's go to the mesh renderer and set cast shadows to off. And right away you can see that looks a lot better. The gradient isn't as clear here because the light is hitting it from the front, but it is still there. So the next thing that we want to do is allow ourselves to kind of control this gradient. And we can do that really easily by simply offsetting our screen position. So to do that, let's go up here and let's create a vector 1. Let's call it offset. And let's drag it in to create a node out of it. And to use this offset, we can simply remove this connection from a split node to a subtract node. And instead put it into a separate subtract node. And we'll simply subtract our offset there. And I'm just going to default this to a value of say 0.6. We can then take the output of this subtract node and put it into this one. So we've just added a tiny step here where we subtract a value from our screen position and then we put it back in and subtract it from our scene depth. And now if we save that and go back into Unity, we can see that we can start to control this gradient that happens at the intersections. You can see that simply by adjusting the offset, we can make that more or less apparent. Pretty cool. But of course, we don't want to add this to the emission of our PBR master node. Instead, we wanted to change the alpha of our material. So let's remove this from the emission and let's plug it into the alpha instead. And if we just save that and have a look at what's going on, it's going to look really, really weird. And the reason for this is that currently this value isn't clamped to go between 0 and 1, which is what the alpha expects. Whenever we go below 0 on the alpha or above 1, things start to get wacky. So what we want to do is, first of all, we want to reverse this because the alpha works in such a way that white values are non-transparent and black values are transparent. And currently we have black values near the edges, which means that we should probably reverse what we have going on here. So to do that, we simply plug it through a 1- node. And that is basically going to do exactly what it says here. It's going to multiply everything with -1, which of course is going to reverse it. And then in order to clamp the value between 0 and 1, we can output this into a smooth step node. We're going to take the ln input here, and it's going to go between, as you can see, 0 and 1. And this is both going to clamp the value to make sure it doesn't go under 0 or above 1, but it's also going to use a smooth Hermite interpolation to create kind of a nice smooth gradient. So let's output this directly into our alpha. And I'm also just going to collapse this and make some room here. And if we now save this asset, we should see, and it's not very visible right now, but we should see that we have this outline near the intersections of our material. Really, really cool. And the reason why these aren't very clear at the moment is because, well, we're just using the default albedo of our PBR master, and we haven't applied any emission. And I think if there's anything that deserves emission, it's a force field. So let's fix this right now. In fact, let's create a property in our blackboards. Let's hit plus. Let's select color. And this is going to be the emission. As the mode here, we'll change it to HDR, which allows us to in here not only define a color. I'm going to set mine to some kind of light blue, but we can also define an intensity of our glow. So I'm going to set that to something like 2.6. Let's drag it in to create a node out of it. And let's drag that straight into the emission. So now we can control the emission of this effect through the editor. And let's save that asset, close it. And now you can see kind of what an effect we're starting to get here. And just to make this a bit prettier, I'm going to go into my post-processing profile and add in some bloom. And that is really going to help sell this effect. In fact, why don't we go ahead and make it just a tiny bit more intense? There we go. So that concludes the first and hardest part of the effect, which is adding the intersections. The next part is actually fairly easy. Here we want to add the glowing outline to the rest of our model. And if you watch the videos for a while, you might know that I'm a big fan of Fornelli. So that's exactly what we're going to be using here. Let's add in a Fornelli effect. Let's set the power to something like 5. And we should probably make this adjustable from within the editor. So let's go ahead and add a setting for that as well, a vector 1. Let's just call it Fornelli power. And let's default that to 5, drag it in and hook that up. And there we go. And all we're going to do is simply add this on top. So let's take this entire thing here, remove this connection. And for our Fornelli, let's go ahead and plug this into an add node. Let's also take the output of our smooth step and plug that in. And now we should pretty much be ready to just take the output of all this and wire it into the alpha. Whoops, there's a node behind here. And as you can see in our preview, the Fornelli effect immediately shows up. And if we save this asset and go back into Unity, we can clearly see it working. So that's really, really cool. And I'm actually going to go ahead and bump down the intensity again because that is a bit too much. There we go. That looks really, really cool. So that is the first two parts of the effect, and the final part is also fairly easy. That is adding a scrolling pattern across the force field. To do this, let's open up Shader Graph. And of course, in order to define a scrolling pattern, you could use some kind of noise or generated texture, but I'm just going to go ahead and use a texture that I found. So I'm going to hit plus here, create a texture 2D property, and let's call this one pattern. As the default texture here, I'm going to input the texture that I found. I found this really cool looking hexagon grid. And let me just show you this real quick. It's basically just, there we go, it's a hexagon grid. There's not much to it. You can use any kind of grid-like structure, just make sure that it tiles seamlessly. So with this pattern, I'm going to drag that in. And of course, whenever we are working with a texture, we want to output this into a sample texture node. And that is going to display it. And what we want to do is basically multiply this together with the output of our outline. So to do that, let's take this entire thing here. So let's take all these nodes, not including that one. Let's move them over. Let's remove this connection here. And let's go ahead and multiply this texture. So we'll take the output of the texture here, put it into a multiply node together with our outline. And let's take the result of that and plug it into our alpha. And as you can see right away, this is going to add the pattern to our outline. And that already looks really cool, but I would like some control over this pattern in terms of tiling. So let's go ahead and drag from the UVs here out and create a tiling and offset node. And I'm just going to tile this in, say, 3 by 3 just to make them smaller. I think that looks much cooler. And let's also try and offset this over time to create that scrolling effect. So to do that, we want a time node, and we just use the standard time here. Let's multiply this by some value in order to be able to control the scroll speed. So let's go ahead and create a vector 1, scroll speed. And let's default this to something really low, like 0.05. Drag that in to our multiply node and hook this up to the offset. And you could, of course, use a vector 2 to control this on the X and Y individually, but I'm just going to go ahead and make it scroll on them both simultaneously. And with that, in our preview here, you can see that our texture is indeed scrolling. And I think that looks really cool wrapped around a sphere. So I'm just going to take all of this and move it down and save the asset. And in Unity here, we need to go ahead and hook up a texture to the pattern. I'm going to choose the same hexagon grid, and voila! We have a really cool scrolling pattern. The very final thing that I want to do, I didn't include this as part of the 3 steps just because it's so small. I just want to fill in a tiny bit of blue on the inside of the circle as well. And in order to do this, I'm going to remove the connection from a multiply node here and instead just add in an add node along with some kind of vector 1. So let's create a vector 1 here. Let's just call it fill. And let's set this value to 0.01. Let's drag in our fill here. And that's all we want to add on top, just to add in a tiny bit of extra. So now inside of our alpha here, you can see that there's a tiny bit of blue in there. And you can of course go ahead and play around with how much you want that to be. But for now, I think that is pretty good. And that concludes our shader. So let's save this, go back into Unity, and there we go. Now we have a really nice looking force field. We can adjust the Fornelli power, the offset on the transition. We can adjust the pattern texture, the scroll speed on that texture. We can adjust the fill in order to kind of fill in on the power shield here. And we can even go ahead and adjust the color to anything that we'd like. So really a lot of options on this, and it's just a really fun and cool effect. Yay! That's pretty much it for this video. If you want to see more videos on shader graph, definitely let us know in the comments. Until then, you can check out some of our other shader graph videos. And if you like this video, consider supporting us on Patreon. Patreon is a great site that allows you to make a monthly donation of your choosing, and you can cancel it at any time. By supporting, you're helping us continue to make these videos in the future. And not only that, by supporting, you also get your name read aloud in the videos for that month, and you get to join our Discord server as a supporter. Ooh, fancy Mr. Supporter joined the chat. A huge thanks to all the people who have supported so far, and if you want to support, simply go to patreon.com/Brackeys. Also, don't forget to check out Skillshare, simply click the link in the description to get started. On that, thanks for watching, and I will see you in the next video. I'm sure Winston would be proud. Thanks to all of the awesome Patreon supporters who donated in March, and a special thanks to Infinity PPR, Cyborg Mummy, Dennis Sullivan, Chris, Shane Cleveland, Face Amerify, Lincoln Chung, Leo Lassette, Runin, Danijil Dusanic, Konstantinos Karensas, Naoki Iwasaki, Gregory Pierce, Rob Farron, Dr. Poon Moon, Erasmus, and Kirill Svidersky. You guys rock!